Okay, then, so fine-tuning large language models. So, I'll be mostly talking about that what is fine-tuning and why we need to fine-tuning the models. But then we'll cover. I'll show you a simple code that how you can write a simple script to fine-tune the OpenAI GPT. But there's just a in a talk I'll be discussing about what is fine tuning and why we actually need to fine tune and why is there a need to fine tune a model. So, then let's get started. And so the agenda would be like what is fine tuning, why we actually need it, and then there are some approaches to fine tuning. So we'll be discussing it and that supervised fine tuning steps. And then we'll have a simple hands-on exercise that how to fine tune. I'll show you. So I think you guys, everyone has used like Chat GPT. So you know that these are pre-trained models like large language models that were actually like created by the OpenAI, and then they were trained on the data. And so there was this data. So if you even go to GPT, and the if you since it was trained till September 2021. So even if you go and if you ask about something related to 2023, so you would guess, sorry, I do not have a context about this. I'm trained. It will give you answer as an because the knowledge cutoff was till 2021. So because it was trained, the data, uh, like the data was not updated. So fine tuning comes when we actually need to maybe if you want to train your data code on your data and like uh, giving it a tone, or there are like different features that you want to give it to your model. So let's take, so it the simple definition is taking a pre-trained model and training at least one model parameter. So you are not training a whole model and you cannot do that, but you are training at least one model parameter. So you are training some model parameter on your data because the data, the previous model, it has been trained on large corpus of data. So but when it comes to fine tune, we cannot do that. I think because we do not have that compute. We cannot. So also it requires like quite effort. And so what we take is that we take a pre-trained model and then we train at least some of the model parameters. So for example, if you say if I let's take this analogy that if you see this diamond, this is a very raw diamond. So you could say this is a GPT-3 model. So GPT-3 model was the base model that was released by OpenAI. Now it is the model that has been trained on the corpus of data. But if I talk about ChatGPT, so when it comes to ChatGPT, so I would say that ChatGPT is actually fine-tuned because it is fine-tuned on the data. That's why it can have it can have a conversation with us because GPT was the base model. So and Chat GPT is the model that has been fine-tuned, and I'll tell you that how it has been fine-tuned. We will cover that later, that how it has been fine-tuned and what are the approaches to fine-tune a model. So this is if that's what I thought of, that a simple analogy that we could give, that uh, if you consider simple a base model and a fine tune. So this is the difference, that it is a very raw. It does not have any like it does not have any how it will be responding, how it will just be completing the sentence, because you know that in when it comes to large language models, it is all about probabilistic. Like it gives us the next word based on the probability. That's why you would see that completions model. So they actually complete the word, the sentence you give. It actually goes on to complete that sentence based on the trained data. So fine tuning is like taking a pre-trained model and training at least one model parameter. And this is the difference. So Chat GPT is actually instruction fine tuned. uh, that is GPT 3.5 Turbo. So that Chat GPT is the model name is GPT 3.5 Turbo that we are using. So this is a simple definition of fine tuning, that you are taking a model already pre-trained model that has been trained, and you are training it at least one of the model parameter. Now, if I show you, this is a base model in fine tune. So you could say that there's this model Da Vinci, GPT-3 model. So there's this, you could see that when we are giving a base model, tell me how to fine tune a model. It is giving like a searches just how I control the making any sense, because you have just given it a data and it has been, so it is just predicting it that that next words, and it does not have any context. But the same Da Vinci, when it was fine tuned, so they fine tuned it, and that was the model text Da Vinci 003. So you could say that on the same uh, model, when we are giving a prompt, tell me how to fine tune a model. So it actually giving us a complete response, and that is actually making some sense, that it is actually responding to our answer. So even if you might have heard about the llama model. So if you go to their page, meta page, so you would see that they have released a base model and chat model. So that's why most that there's a base model is there as well, and there's a chat model. So chat model is already trained on the data, that supervised data, and we'll cover it, that what is supervised and self-supervised. Okay. So why fine tuning? The question comes like, why fine? So for example, let's say you have a model that has been trained on this amount of data, but you want to customize it for your own use case. Obviously, it has been trained on like large amount, like large corpus of data, but obviously most probably it will not be like the use case that you want to do. It might not be trained on that data, that custom data, that specific data. So what happens that you cannot train the whole model again on uh, on your data. Like even if you can do, there are many, like obviously the compute cost, uh, the compute that we need to train a single model, that is not very easy. Even like billions of dollars was spent on training the GPT. So there was this, like you can see that chat GPT actually had instruct GPT, it has 1.3 billion parameters. So you could say parameters, if I say that there are neurons or neurons in neural networks, uh, so that's how you could say that if like it has uh, 1.3 billion parameters, so it has like 1.3 billions of, you could say that, uh, weights that was assigned to that network. So, but uh, uh, it actually performed better than GPT-3, that was 175 billion parameter. So, and it was obviously smaller fine tune, because you could see that it is just 1.3 billion, and the GPT-3 is 175 billion. So, the fine tune models can actually most of the time outperform a large base models uh, for specific tasks. This is that is why we actually need fine tuning, because for your data or for your custom data, uh, and obviously the model of the base model that you're using, it could if you even go to ChatGPT, most of the time, if if the question does not have any answer, it will just answer it, and it will the response will not make any sense. So that's what we call it hallucination. So when we are like training on our data, so it has more context of our data. uh, so this is like that is why we need actually fine tuning. And even if you want to like give it a tone, that the way if there's any data you want to maybe summarization, if you want to summarize, there's a task of summarization, and you want in certain way the output. So the base model wouldn't work on that way, wouldn't do that. So even most of the use cases were like people were fine tuning it in a way that you have to answer us in this tone, and you have to use this language. So that's where fine tuning comes. And even if you want some responses in that some format, some structures, so you could fine tune your model by giving the data by those specific use cases, and that is where like fine tuning comes in handy. Okay, so let's go ahead. So there are ways of fine tuning. So three ways to fine tune your LLM, large language model. The first is self supervised. So what happens is that in self supervised, you take a corpus of data and you just give it to your model, and you train on that corpus of data. Just give it a data, and like it is like just feeding all of the data. It is unstructured data. There is no like it has no, just all unstructured, like even if it are text or anything, uh, it has like no sequence or any it does not follow any pattern. So you just give it. So base models are like pre-trained models. That's how that is the first step that they are actually trained. So like large corpus of data, they were like they were fed, and that is that's when they start to based on that data, when you give it some query. So the data that it has been trained on, so based on the data it will actually start to predict, because it has that data in its memory. And when you will give your query, so based on the probability that okay, so I have this data, what which word has the highest probability to come, so it will complete. So that's how it just goes for completion. So this is the self-supervised learning. That was the first part when even OpenAI was trained. So it was the very first step of like finding. So here you are just giving it a data, and completes. So even if you use other models like uh, maybe Llama or different open source models, so because they have like their base models as well, they have like their chat models as well. So in base models, if you give it
Hi, Heather.
like anything,
Sorry to
yeah,
interrupt. Can you please hide this notification that's showing on the bottom of the screen? It's hiding the text.
okay,
Thank you.
is it okay?
Yeah, yeah, it's fine
So
now. Thanks.
okay, thanks. Okay, so that just keeps on going, and that does not have any context. Like it actually completes what you have given, and that comes to supervised fine tuning. So in supervised fine tuning, you have labeled corpus. So if you if when we start with the very traditional data science, so we have data sets which has a x value and it has a labeled output. So we train that model. So in the same way, for example, you say you have question and answer pairs. So it will have question, it will have answer to it. Question answer, or uh, you could maybe you could have some maybe some structured output. So if you have some query and it has some you wanted to give the output in that structured maybe JSON output or something. So you have created a data set in that way that it is giving us a like it has a uh, output as well, like labeled output to your query or your question. So the data set would be like the whole corpus would be would have a labeled corpus. Mostly the question answer pairs. We will be using the data set in our uh, exercise as well, hands-on exercise. So this is called supervised fine tuning, and that is where most of the chat models, how the chat models that are trained on, that is how they are like trained on after the base model, and then they are the supervised fine tuning where they are given a data in this format, so they know how you have to respond to this query. The third is RLHF, reinforcement learning from human feedback. So what happens here is that first of all you are like uh, here comes a, like a human interaction. So when even uh, OpenAI, even there were mechanical turks that was used, people used the laborers were used to like even a few days back. I don't know if you guys have experienced that. I was using ChatGPT and it has this when I asked for this summarization thing. So it actually then after it gave me output, it gave me two responses, A and B. So it actually asked me to select which is the most better response. So I was actually as a labeler, I worked because you they are now. So that is where you so in what happens in this technique is that after you have a pre-trained model, you after this pre-trained model, you what you do is that you ask it to generate completion, and then you ask a human to like rate the output on human preferences, that which output is better, which output is like based on the human preference, and based on those preferences you actually trained the model, reward model. And then what you do is that you combine the reinforcement learning and the proximity this model, and then you join you join these models for the final output. So what actually happens here is that you are using a human preference. You like use humans to like ask which response is better, and then you take that response and then you again train your model. So it has, because the first time it generated like it doesn't, the human would not there, it generated out of its trained data, and then you are taking human in the loop. So you are asking, so that is that's what I was telling you guys. I actually because I did not see that before. A few days back I actually saw that I had to choose which summary was better. So it was option in the chat GPT. So I clicked that, okay, this one. So what would happen is that after I selected it, it would go at the back end, it would go, okay, so this answer out of this one is good, and then model will be trained on the same data. So that will be trained, that's how a model will have more context, that what type of summaries or what type of responses are human oriented, or people are actually considering these type of responses. So this is one of the fine tuning techniques that is and these were actually used in even in our when chat GPT, I think it was GPT-3 or something, when they released actually. So these were the steps that were followed to fine tuning the base model actually. Okay. So now parameter training methods. So you have seen that if you have like uh, if you have heard that there was a recently open source model Llama 7B. So it has 7 billion parameters. 70B or 13B, Falcon 180B, even the GPT-3 is 175 billion parameters. So these are the parameters that are actually trained on our data. So these now what happens is that like there are many methods to actually uh, for the parameter training. Uh, the first one is retain all parameters. So you what are you doing is that you are just considering the whole of the data, and you are training all of the parameters of your neural network. You are training all of those networks parameters on your data. But as I said that that is actually not possible for like a single person, because you would need compute, you would need effort, you would need quite a lot of effort for that. So then there that's why like uh, we a person mostly we cannot retain all of the parameters. But then obviously there comes transfer learning. So in transfer learning, what we do is that we are like training like the head layers of our neural network. So not all of the data, but some of the layers which have the output embedding. So we are actually training those on our data. But what happens is that in this technique that it has some limitation that maybe most of the time the it has, I think, catastrophic forgetting. That is what it is called, that it forgets most of the pre-trained data that it was trained on. So obviously we do not we want to retain that. So transfer learning is have been used actually, but now there was a parameter efficient fine tuning. So I wouldn't go much deeper into it because then it could we could like go tangent to our topic. But yeah, parameter efficient fine tuning, and one of the techniques of this in this model uh, is this, that you guys, if you guys have heard LoRa, low rank adaptation. So the low rank adaptation was a technique. So what we are doing in that method, so I'll give you a quick overview, high level. So what we are doing in that method is that we are freezing all of our weights, the pre-trained weights, and we are actually injecting our trainable parameters. So you could say that we are actually adding our own trainable parameters that are actually trained on, and we are freezing the pre-trained weights. So we are not losing that training as well. But what we do here is that is why we call low rank adaptation. So rank is it is all about the matrix multiplication. So because we have the weights that we have they are in like the values, they create a matrix. So what happens is that in LoRa technique is what we are doing is that we are adding our trainable parameters, and we are actually and what happens in this technique is that we actually lowering the rank of our matrix. So when we, for example, when our trainable parameters are added, so what happens that obviously, because if you go on to train all of the parameters, that is not possible, and that will like that is quite an effort. So what happens is that you are just adding your trainable parameters that are trained on your data, and then they are added to that model in LoRa technique, that is low rank adaptation. And that's how our model, like when you, even I have tried that on open source models, I did that on Llama, and it was pretty good actually. So right now OpenAI has not actually uh, mm, has not released how the fine tuning that we'll do, how which method is being applied. We can maybe assume that it is actually low rank adaptation, parameter efficient fine tuning maybe, or it could be there are many techniques of parameter efficient fine tuning, because we are fine tuning some parameters. But the most common and the most uh, optimized one is the LoRa, and there's then quantized. That is a different thing, the quantization. So I think this is how like this is how we are actually fine tuning. And fine tuning, the LoRa technique is all over the place these days. It was, I think, uh, maybe it was October or I think it was March. Yeah, there was this paper that was released, Tim Demeter or something. I'm forgetting the name of the author. And there was this one guy, and so some folks actually, so they actually suggested this technique. Obviously, it is actually built on the previous techniques that were there, but it is very like it is quite better than previous ones, and it is being used for training. Then supervised fine tuning steps. So just I'll give you quick that. So first, you are like, if you want to supervise fine tuning, you choose a fine tuning task, maybe summarization, question answer, or text classification. So you'll have you that first you have to select that what task you want your model to be fine tune now. After you have selected that, you have to prepare a training data set. So maybe it could be output pairs, like input and output pairs, and we'll have to like tokenize and truncate and add some. That depends, because you will have to. Uh, there is certain formats for Llama 2. There was this format that was given in the paper for fine tuning, that you have to follow this syntax, I would say, or this pattern to create your data set for fine tuning, and then you have to choose a base model. Maybe you could experiment with different models and like choose the one that, and then you have to fine tune via supervised learning, and then you can evaluate the model performance using, maybe there are many frameworks or some traditional metrics like blue or rouge. For summarization, maybe you use the blue metric or rouge metric for score. So these are some few steps. Okay, now let's maybe let's go to our, and let's maybe I would first tell you like, so okay, so uh, this is the OpenAI website, and like I just wanted you to guys go through, so you could see that they are like prepare and upload training data set. So I've actually prepared the data set. I'll show you, and like train a new fine tune model and use your fine tune model. So there are three steps when to use fine tuning. Like there are, because fine tuning comes like in the like, because we have the RAG approach, uh, retrieval augmented generation, we have prompting techniques. So after you are like, if the task that cannot be like, you are not getting the satisfied results from those techniques, then you can like go on to fine tuning. So common use case like setting style, tone or format, and other qualitative aspects, and like if you want like desired output, this output format. So these are some use cases that are actually used for fine tuning, uh, fine tuning the model. So okay, so now I think we can get started with our. So Dua, can you tell me if my screen is visible?
Yes, we can see that you are download.
Okay, yeah, thanks. Okay, so I think we can get started with. So maybe I should show you. So this is the data sets. So we have our LLM bootcamp going on. So I just created a simple data set that. Uh, so there's as so like these are the questions related to our bootcamp that is going on, where we are covering all of these, like from start to end, from foundational models to the end, and fine tuning is just one of the part of that bootcamp. And we are coming like whole, it is a very in-depth whole 5 days bootcamp, 40 hours now. So I just took that data and just created simple 40-50 questions out of that, uh, based on the data. So maybe I think I should show you one. So you could see, as I was saying, that you have to follow certain format for like, uh, there's creating a data set. So you can say that messages, and then you have to give it, assign a role for system. You have to give it system a role, like what it is, like it is a factual chatbot or whatever the chatbot. You could say that you are a you are a summarization or certain expert, and you have to do this. And then user, what is the content? It could be a question, or it could be, you will have to actually convert it the way you want it to be. So let's get started. First, install OpenAI. Think then let's okay. So OpenAI, because we really need dependencies. So import OpenAI, then we are importing OS, and then since we have to use the key. So dot dot n from dot n. import load load dot and import load from OS import. Okay, I think these are the dependencies that we'll be requiring for our. Then let's load dot and then we can define our OpenAI dot API key equals to OS dot. And so I have created an environmental variable where I have saved my API key. So I'll just calling it from right from here. Or load it. Okay, so you could see that now we have as we saw that there are certain steps that we have to follow. You have to first upload the data set, then uh, after uploading the data set, uh, first create a data set, and then you have to upload, because you have to upload the data set to the OpenAI server. Otherwise, it will not, because the data has to be uploaded there for training. So maybe upload data set. So this is the data set that I'm just calling. This is the simple Q&A data set that I'm just calling here. So train OpenAI dot file create file dot create. Okay. And here, like, we'll be defining our file, the path to our file, that where our data set is stored, and then what is the purpose is obviously fine tune. Then okay, so get file equals to open. Then we can my data set name is fine tune Q&A dot. So this has to be the data has to be in JSON file. So fine tune Q&A dot XML, and then we are okay. Then this is also, I think, available on OpenAI website, so you could copy that from here there as well. Just so, and then we could see the response. What's the error fine tune? What I think is that fine tuning. Okay, fine tuning. Okay, so you could see that file, object file, the ID, our data set has been uploaded to OpenAI. We have been given an ID, so we have to keep this ID so that we could keep a track of our like data. So I'll save it in a just as like, maybe if you want to like track it or something. So train ID. And then now we have to create a fine-tuning job. So you have uploaded the data, and then now we wanted to like create like start fine-tuning. So creating a fine-tuning job. So create fine response open AI dot fine-tuning job dot yeah, it was fine-tuning job. And there's a training file. There's this parameter training file is equals to, we could give directly our, because we have saved it here, we could directly just give this our as a parameter, and then we want our model. So as we see that only GPT 3.5 Turbo is like they have allowed it to fine tune it. You cannot fine tune the GPT-4, or there are other models. There are some other models like DaVinci and Curie. These the models that are also fine tunable. You can fine tune these, but GPT-4 they have said it like in the at their website that in the coming upcoming time they will allow to fine tune GPT-4 as well. So GPT 3.5 Turbo. So I think you maybe. So if I now maybe should keep the job ID. So now job ID is to like track the response of our fine tuning. So I'm creating actually because if I show you the response here, see so response. You could see that our model has started the fine tuning has started finished that it is not finished. So obviously how do we know when it will finish? So I have already fine tuned, so I'll be using that because it takes some time, 10 to 15 minutes. And also you could you could save this, and now if you want to like track, so you could I'm just there they have given it like fine tuning dot openai dot fine tuning dot retrieve fine tuning dot grid, and then you could give job ID. So you could track actually using this that if it is so obviously if we see I suppose that it wouldn't be. I have already trained the same, so I'll use that. So you could see that it is null. So after it is trained, you will get a mail that so you will actually get a mail regarding that okay your model has been trained, and it will give you the model ID. So in response, so I have actually saved my model ID. So this is how you will getting the ID after it is trained. So my mine one is, since it will take some time, so I have already trained one. So this, and you can like after time by time, it depends on the data. It took me like also this depends on how much load is on the server. So they have already said on the website that if it is like there's a much load, so it could take quite some time, but depends on the load at the server. So it took me like 10 to 15 minutes for I think 15 minutes last time I find it. So but I have the fine-tuned ID. You will get this ID and you can just save it here. So I'm just running it, and after that, we can like test our like if you want to like see how. So maybe I am just creating some. Let's just create test message. Yeah, test messages, and we can create a dictionary. We give it a role uh, role and content. So and I had actually tried the code before. Yeah, that's right. And the content is we have just few questions. Let's just say what programming and languages are so syntax. User does not have this. Okay, maybe I think user would have comma. So your role is the user. Okay, yeah, and then content. Okay, so we have the and now we can like test our. So first, let's try our like uh, OpenAI chat completion. Chat completion. Dot create, and we can take our model. Can take our model as model equals to GPT. Yeah, just 0.5 turbo. So here we are using the turbo, and then we can messages is equals to test. So we are retyped it. Okay, test messages and completion. Okay, okay. So here we are using the like custom model. So let's load it. So there's a GPT 3.5 Turbo, that's the model right now we are using, and we are giving it the simple queries what programming languages are using the curriculum. So print. So we have saved it in completion. dot choices, the first one, dot message. Okay, so you could see that it has generated. Now the answers were not that long, and it has just generated. It has the context, obviously, that uh, like it has been trained on the previous data, but it is generating the whole goes on to generate uh, anything. Like it is kept on hallucinating. But if I, yeah, should, we can just copy this and model. Now we can, this is the model ID, so we can just replace here the model id, and then we can print completion. We can name it completion one, or yeah, and run it. Now we are using our fine-tune model, and let's see how it answers. Does it got, has it got the tone, or has it got the length of the answers? So it's taking some time to getting fine, like to generate, to load the model, fine-tune model. Okay, let's scroll. So it is loaded, and then we can say completion one, and then we can answer and see for you. So Python, JavaScript are the primary used. Also, it has answered it. So the answers were actually not exact answers, but you could see that the previous one, the model that has generated, that it has the program you're using, depending on the educational institution and the specific. I think nothing is like exactly to answers, but here it has got the tone, that the one liners, and there's a difference. JavaScript is not being used, Python is being used, but it has actually got the it has the pattern of our data that has been fine-tuned. There were a few questions that uh, maybe I think we can just replace it here. What? So just run it, test cases, and again the C. So no, so you can, you don't necessarily, so you could see that it has a difference between, and this one is actually like a exact. No, you don't need parameter, basic and a foundational concept. Like this is the exact. I mean, somehow very similar to the answer it generated. And in this one, you do not necessarily need prior machine learning and start machine learning, however, having a basic understanding. So additionally having experience. So this one, the first model, and obviously the data was very few. I think it was for 30 40. Yeah, 30 I think, yeah, 30 to 40 questions. The data was not that much. Even OpenAI suggested getting started with 50 like Q&A, or uh, I think question and answers. So depends on the data and the task you are doing. And also here we have just like we did not using the validation data set, where it then when we are working, you have to add prompts as well. Like when in a fine-tune model, you have to add prompts. So I've not used prompt, I've just directly shown you a very quick. So what you can do is that you can actually add prompt templates. So it will be more like, then when it will have a prompt template where you will be defining it, so it will have more context. So that's where it comes in handy. As I show you that even the OpenAI suggests that after you have tried the other approaches, and you see that these approaches are not that suitable, and they are not working good for your scenario, then you can go into fine tuning. Otherwise, the you should go, there is the very popular that even at DSD we have been even using in our project, that is RAG. uh, and uh, you might have a retrieval augmented generation. So this is the approach that has been, and it actually caters most of the time, mostly use cases related to chatbots and all. So I think then the prompt engineering, you could like create prompt, and prompting techniques they are out there, which you can use to customize your responses. Then if that does not work, so I think then you can like come to this method fine tuning. And then obviously like you will have to have some data sets, and then you will have to, even in that fine tune model, you will have to add some prompt, and some you will have to give it some context. So yeah, so that's it. I think that's it from my side. Uh, if there are any questions or anything, I think I should stop. Okay. So let me. So so it depends on, okay, so I think Ravindra, if you use open source model, what, so it depends on where you are deploying the model, because if you are deploying it for open source model, obviously uh, you actually need a high compute to run those models, uh, uh, because like I use Llama, I couldn't actually run it on I not run on a regular system using the obviously you're using the compute, so there can be some privacy challenges. But if you have your own compute, so obviously you won't have the privacy problem, uh, because then you can, if you have the GPUs and high compute to to run those models, because those the only limitation is of the running those, because that's why you would have heard the quantization word. The models, people have been quantized the models to 4-bit quantization, so they have actually reduced the size of the model. It is like reducing the precision of the model, and they still work pretty fine, so that one can use on local, still maybe Google Colab or something, the 4-bit quantized 7 billion models. So I think, yeah, then it will be that where you are hosting the model or deploying that model. So that is that. Then obviously there will be some. But if you have your own setup, so it wouldn't be a problem for you. Okay, so I think I did not. I've not added it to the GitHub. Uh, I'll add that to GitHub. Okay, David. So labels, David, in context of supervised fine tuning, labels, you have, there is this, uh, you will have to convert the data. Obviously, the data will be textual data you are getting. So we'll have to convert that data in a Q, mostly in a, not Q&A, but Q&A is a very simple, but like one query and response. So you'll have to break it into, there would be some format that are given according to this. For Llama, some it is some you have to chat or conversation, so you still have to convert that to in that format. So it will be like, labels are like the answers or the responses to that questions, or the chat, if that's a chat, that how the chat is going ahead. So that's how the labels would be in the supervised. No, so it was called low rank adaptation. Low rank adaptation. So LoRa, you could. So, no, actually, you cannot do this, because uh, OpenAI has, the GPT models are not open source models, so you cannot apply those models on GPT. But on open source models, yes, you can do that on the open source models like Llama, Falcon. They just came out, Mistral, Orca. There are like so many models. I think, so you can do that on those. I have done the PEFT on parameter efficient fine tuning on the Llama 7B. That was a quantized one. So, yeah. If I'm so Hessa has asked that if I'm going to fine tune Llama 2 on Q&A task using, okay. So, maybe I'm not getting the how to provide the context for every specific question. So obviously the context could be, if you want, because the you are giving a Q&A, the input and output. So context could be given in your on the prompt that you are using. So you could give like about the whole of the data set, but but like within context, I you just have to create some where like but whole of the context of the whole of the answers, so you could give that uh, you could give that in the prompts after that, because there's a you will be adding some a prompt when you will be like if you're using the rag approach, you will be so even if not using the rag, even if it is a fine-tuned one, so you still can give a prompt to the model about that the data. No, it doesn't actually. So it actually depends on because we are actually. So what happens is that you are using a OpenAI service and fine-tuned model is actually deployed there after you have uploaded the data set. So mostly server is down. If I take that hit up in that sense, so mostly server is down and uh, the performance is like for me. I think I have been using mostly open source models. So uh, maybe if I get a chance, so I would cover one of the maybe Llama in the coming days. So I have like used that most of the time. But so far, OpenAI GPT has been a good experience, but not that much I would say because uh, I found that more better. I think it is just my opinion. I could be wrong obviously, but for my use cases that I fine tuned, so I actually found the Llama much better for fine tuning. But yeah, in general.